points. 7.6, learning targets. Students will be able to factor polynomials using the greatest common factor, GCF. Students will be able to solve polynomial equations by factoring. Okay? A lot of big words in there. We're kind of getting used to the big word polynomial. We still don't like the big words greatest common factor, but they're not too complicated. We'll be okay. Order of operations. Terms. Examples. Practice. Super quick today. So, factoring polynomials using the greatest common factor. Here are the steps. You don't really need to write these down, these steps down. The examples will be much more helpful. But what we'll do is we'll look at some of these polynomials and we'll find the greatest common factor of each term. Okay, remember the terms. The terms would be like 12x squared. 12x squared would be one term. 4x would be another term. So if we have 12x squared plus 4x, what would be the greatest common factor between each term? Starting with 12 and 4. What's the greatest common factor of 12 and 4? 4. Yep. So we found the greatest common factor. We'll just save that in the corner for a second. Then it says use the distributive property. Here's step 2. Use the distributive property to write the polynomial as a product of the greatest common factor and its remaining factors. So that sounds a little bit complicated. All that means is we're going to pull the greatest common factor out of this binomial. So our greatest common factor is 4, and we're going to pull that out front. Now, we pull 4 out of 12. What does that leave left over? We factor a 4 out of 12. It would be minusing, but I like the way you're thinking. 3? 4. You would have a 3 left over. When we're factoring, we're dividing. You'd have 3 left over. Now, if we factor 4 out of 4, what's left over? 1. That's where we're using the greatest common factor. Now, there is one little part of that that we missed. If we look at the term 12x squared and 4x, besides just being able to factor 4 out of 12 and 4, what other thing do those two terms have in common? What? If we look at 12x squared and 4x, we factored a 4 out of the 12 and the 4. Right? They both had a 4 in common, so we took it out. What other thing do they have in common? They both have an x. Yep. They both have an x. So not only are we able to factor a number out, but we are also able to factor one of the x's out. So if we were completely factoring this and putting it in its factored form, we would have 4x squared, or 4x on the outside, because we took an x from each term. And that would leave us with 3x plus 1. We can check these by just using the distributive property that we have been doing all week. If we wanted to see, we started up here with 12x squared plus 4x. If we wanted to check it, we could just redistribute that front number, that 4x. We would get that original answer back. Let's look at a couple more examples. So factor each polynomial. We're looking at 2x squared plus 18. What is the greatest common factor between 2 and 18? 2. You can pull 2 out front. Now, do they both have an x, or do they both have anything else in common? No. 18 doesn't have an x, so we can't pull an x out of both of them because they don't both have one. So we just pulled the 2 out. That leaves us just with x squared plus 18 divided by 2. Where we factor 2 out of 18, we're left with 9.
Wait. Why did you get just x?
So we factored 2 out of this whole thing, right? We said 2 and 18, their greatest common factor is 2.
But
So if we're pulling the 2 out of each one, pulling the 2 out of 2, and pulling the 2 out of 18, then 2 divided by 2 would just give us 1. So that just leaves us with 1x squared in the front. We don't need to write the 1. You good, Michael? Do you have more? You want me to go over that one more time?
Yeah.
Go over it again?
I'm sorry, guys.
I think more than just you probably like us to go over it. If we look at or remember our steps, the first thing we're doing is looking to see what the greatest common factor is of our numbers. Nice shot. Greatest common factor of 2 and 18, we said was 2. When we write that number out front, then we're writing what's left over inside the parentheses. Okay? So what they do in some middle schools, because in some middle schools they do factoring in 6th grade. So what they talk about in some middle schools is to write it. If you pull, let's say you pull some number out, then what's left over, you're dividing by your front number. So like, we just pulled a 2 out. So now inside our parentheses, we have 2 divided by 2 over 18 divided by 2. So we're pulling that 2 and putting it out front.
We don't gotta do that, right?
That's how we get x squared plus 9. All we're doing is moving things around. We're not changing the value. We haven't solved for anything yet. We're just moving things around. We're pulling the greatest common factor and putting it out front, and then we're writing the leftovers inside the parentheses. If we look at our second example, what's the greatest common factor of 15 and 10?
The 5?
5, yep.
Oh, yeah.
Now, is there anything else we can pull out of 15y cubed and 10y squared?
Did you pull the Y on?
We could pull a y. Can we pull more than one y? We could pull 2 y's, right? 15y cubed has 3 y's with it. 10y squared has 2 y's with it. So in common, they have 2 y's. So we can pull both. Now, what's left over? After we pull 5y squared out of 15y cubed, what's left over? 3 y's are left over with 15y squared, and all that's left with 10 cubed is 2. It's not too bad. Now, building off of what we talked about yesterday, you could totally see where they would change the direction, which we're about to do, and ask you to find the values of y when y equals 0. To pull it all together from yesterday. So that's what we're going to get to right here. So they may say, solve 4g cubed equals negative 6g. What it means by solve is find the values of g. Find the values of g. The first thing we'd want to do in this situation is make sure that our equation is set equal to 0. So we just need to bring that 6g to the other side. So now that it's equal to 0, we can start to move things around to figure out what those g values need to be, just like we did yesterday. So if we look at, right now we can't look at those g values and we can't swoop, there it is, we can't do anything to really know what would make this equation equal to 0. So we have to factor some numbers out and letters out to try to get it in a form that we can see what's going on. So what's our greatest common factor of 4 and 6? 2. Can we pull anything else out. What? G. They both have a G in common. We're left with 2G plus 3. Now could we figure out what those G values need to be? Tad, what's one of our G values that would make this help us solve here? What's one of them? Someone help them out. 0. We plug 0 in for G, just like we did yesterday, we'd be all set. What about inside the parentheses? What would make the parentheses 0?
No.
We need to do a little swooping.
Little swooping?
Little swooping.
Little swooping.
Joe, what do you think? What would make it 0 in the parentheses? We swoop.
2/3.
2/3. So you're swooping the wrong way. Okay? You're taking here. Oh! Nope, yeah, you are.
I was like,
And you're swooping here. Okay? We want to swoop the other way. So we start with our number that's with the variable. We want to swoop here. Then we need to take the opposite. So -3/2. Thanks for trying that, Joe. Because I think a lot of people were swooping the wrong way. Yeah.
Do you always take the opposite?
Yep, because think about it. If we just put regular 3/2 in there, it wouldn't become 0. It would just be higher positive. So that's what we're working on today. For these, you don't have to solve. So you just need to factor it and write it in the form like this. Or write it in this form. Or this form. If you want to solve, you can. But for each of your answers, I should see out front, I should see the GCF, and then the leftovers inside the parentheses. Yes?
Robert.
Yeah, great. Good job. We have some practice problems today, but now would be a good time for you to go back and look at what we did yesterday.